Welcome back. In this video, we begin our discussion of Lesson 7, which is about graphs and level curves. In Lesson 7, we're going to study the key concepts for level curves of multivariable functions by demonstrating the ideas with a focus on functions having two independent variables and one dependent variable. We take this simplified approach because once we get these ideas down in the two variable function case, we can extend the focus to three or more input variables. We begin our adventure talking about level curves by focusing on functions that are explicitly written where the output variable z is given as an expression of x and y. Here we have an isolated output variable, and then here are our two input variables. Of course, we call f a two-variable function. Let's get really specific by what we mean about a two-variable function. To do so, we'll introduce a definition. We say that a two-variable function z equal to f of xy assigns to each input point x comma y in the domain D a unique real valued output. Of course, we've seen our function maps that say f goes from a domain D into the real numbers, where D is a subset of R2. Sometimes it's convenient to identify how many input variables there are inside the map. And we can do this by identifying both the domain and the domain space as well as the codomain. So here we can immediately tell that f was a two-variable function because the domain D sits inside of R2. So you would read f is a function from D, which is a subset of R2, into R. Remember from a previous video that we said that the graph of z equals f of xy is a set of ordered triplets x comma y comma z that satisfy this equation, z equals f of xy, in other words, that make that true. This graph is often represented as a set of points on the coordinate axis in R3, which we can visualize graphically, in our case using Mathematica. We have some more formal notation to cover, just to get this out of the way. Recall that we said that we have this domain D of the function f. A very intuitive way to think about this is the set of all valid inputs. If you have a two-variable function f of xy and the output variable z, we say that the domain of this function is the set D. You can write this as the domain of f equals D. This notation, DOM, input of function f, you read that as the domain of f, and it's equal to the set D. Just like we defined the domain, in this case for a two-variable function, we say that it's a subset of the domain space R2 from which the domain is chosen. We can also define what we call the range. The range of a function f is the set of achieved output values while we run through all inputs in the domain. So the formal definition that we might use is if we have a two-variable function z equals f of xy, the range of this function is the set of all output values z that result from sampling f at all input values in the domain. You can write this in set notation. This is a bit of a lift, but I think we can do it. As the range of f, so RNG, range of f, is equal to the set of all z in the codomain such that there is a input ordered pair x comma y in the domain where the output z is achieved by evaluating f at this input. So it's the set of all achieved output for at least one input in the domain. That gets us ready to start thinking about level curves. Before we do so, let's look at an example of how we might analyze the domain and range of a given two variable functions. And then we're going to get our hands dirty. Are you ready? See you in the next video.